Today's activity is designed to find the speed of sound in air. We know that's somewhere around, from your quiz that you just wrote, somewhere around 343 meters per second, depending upon the temperature. We want to find out exactly what it is based on actual experimental data. So what we're going to use is this resonating column that you see up on the board and that you see in my hand right now. How does this work? Well, we know that there's an air column in here, and we know that that will vibrate. If I blow across the top of it, it's hard to produce a sound when I blow across the top of it like it is when I blow across the top of a water bottle, simply because it's so long. Okay, but bottom line is there would be resonance taking place in there. It's easier to hear the sound if I actually hit a tuning fork against a little hammer like this. By the way, when you do this, don't hit the plastic side of the tuning fork on it, because you can dent the tuning fork a little bit, change the frequency of the tuning fork. Hit the rubber side against it like this. If I hold this up here, you still don't really hear a sound in there. Why not? Well, when I blow across the top of a water bottle, I'm producing a million different frequencies, and the ones that correspond to the resonant frequencies stick around. Okay, when I hit the tuning fork, it's producing a very specific frequency, in this case, 261.6 hertz. Unless the resonant frequency of this is 261, then it's not going to resonate. You're not going to hear any sound in there. So what we want to do, if we're using a tuning fork that's 261 hertz, is adjust the length of this air column so that its resonant frequency is 261, so that we end up hearing that sound, that resonating sound that takes place within that. Does that make sense? So what's the best way to do that? What's the best way to change the length of it? It's going to add some water to it. If we add some water to it, like this, you're going to do this as well, but watch me very carefully. Okay, you have to be very, very careful as you're doing this. First of all, don't put the inner tube all the way down to the bottom of the outer tube. In other words, make sure this part right here, is not sitting against the bottom. If it is, okay, then the water, when you pour it into the inner tube, is going to stay in the inner tube. Okay, we want it to go throughout this. Okay, so we want to go in the inner and outer tube. If I fill it up where the inner tube isn't touching the bottom, or the alternative, you got to be careful if you do this. The alternative is just to take that inner tube out. Okay, I wouldn't recommend that. Why not? It's easier to do, but I wouldn't recommend doing it because you won't know how much water you got to put in, right? Because go and put that back in, it ends up overflowing, right? Let's pour it in the inner tube here. Just make sure the inner tube isn't touching the bottom. I can't actually see where it's coming up there now. Can tell me when it's getting close? You can hear the sound in there. You can hear it resonating right now, actually. Okay, we're gonna leave it around there. We'll put a tiny bit more in, but make sure you don't overflow it. Make sure you don't even fill it quite to the top. Okay, right there is good. The other thing you want to be careful of is that the rubber stopper in the bottom is attached firmly. They tend to like to fall out. There's masking tape on most of them. I won't guarantee the strength of that masking tape. It might have been put on 2 years ago. Okay? What I would recommend you do is either keep it on the ground like this so that the water's not going to push the stopper out of the bottom, or you really reinforce it with some new masking tape. Does that make sense? It seems like just about every class, probably 3 out of 4 classes when I do this activity, somebody's rubber stopper pops out the end and water goes everywhere. About a half a liter of water, so it goes everywhere. Okay? Try to avoid that. Now, can I have you hold this for a second? Now what I want to do, actually, I'm going to have you do this. Okay, I'm going to have you, Spencer, hit the tuning fork with the rubber side there. And then I'm going to have you hold it up here. Okay? Now, I'm going to keep, let's see here. I'm going to lower this down. Okay, right now, you can see that the top of this air column, okay, at 0, the bottom of this air column is where the water is, so where the meter stick on there, where the increments on there are written. Right now, it's 67 centimeters long. Okay, I want you to hit that. Okay, put it up near the top. Okay, nothing. I'm going to shorten it. Hit it again. You can hit it harder. There you go. You follow it as long as I go down. Nothing. Go again. At the end of the tuning fork by it. Starting to hear something. Hit it again. Again. Here, let's take this in actually. This is easier to do. Just give it a good whack here. Hear that? Starting to get resonance in there. I think I went past it. I think it's occurring somewhere in there. Make sense? You hear that? You guys hear the difference there? Okay, did you hear it? Oh, no, there it is. Right in there somewhere. When you hear that resonance taking place, I want you to record the length of it. I've got it at about 31 centimeters there. Does that make sense? Your first one should be, depending upon the frequency of the tuning fork that you're using, somewhere probably between about 15 centimeters and 35 centimeters, give or take a little bit, okay? So if you started at a length of about 60 centimeters, you're not going to hear anything right away. It's going to be somewhere probably between about 15 and 35 centimeters. Now, if you have a really low frequency tuning fork like this one is, 261 hertz, you're going to be closer to the 35 centimeters. If you have a high frequency tuning fork like 500 hertz, you're going to be closer to the 15 centimeter mark. Does that make sense? So look in that range first. You hold that for me, please? Thanks, so it doesn't fall over. Look in that range first. Record the temperature of the air, which is in the room right now about 20 degrees Celsius. Okay? It might be 20 point something, but we're going to go with 20 degrees Celsius. Record the value of the frequency of your first tuning fork. For me, what did I say that was? 261.6 hertz. Record the length at which we heard it resonating at. What did we say, 31 centimeters? 0.31 meters. Make sense? Then do it again, but don't look for the same place. We already found that one. Look for the second one this time. Okay, this time we're going to start with this thing really far out because the length is going to be longer than it was the first time. Oh, I think I missed it there. Somewhere around here. Right in there somewhere. Can't hear that very loud. Right in there somewhere, about 94. It's about 94 centimeters. So the second one, here, I'll give this to you again. I'll spill that water, thank you. The second one is going to be about 0.94 meters, and then so on. Repeat this with a different tuning fork. Maybe this time you're going to use a tuning fork of 450 hertz. Okay, you're going to end up with a different length, and a different length for the second one as well. The length for this one is going to be smaller than 31 centimeters, so you know where to start, right? It's going to be somewhere in that probably 15 to 20, 15 to 25 range. Okay, and then this one is going to be correspondingly lower as well. Does that make sense? That's your data. Okay, that's all you have to collect for data. Then your analysis is, first of all, to calculate the speed of sound using this equation. That's easy enough. Okay, we know the temperature is 20 degrees Celsius. You had to do this on your quiz, 331 plus 0.6 times 20. We know what that's going to turn out to be. Then, here's the tough part. It's not really tough, but the toughest part of this activity is to use the equations that you derived in class for the first and third harmonics. The first harmonic, we know for a standing wave that's set up in a closed air column is going to be, what do we say, L is equal to a quarter lambda. Lambda is equal to 4 times L. F is equal to V over lambda, or F is equal to V over 4 times L. Calculate the frequency there. Sorry, take that frequency. Sorry, you're not calculating the frequency, we already know that. Okay, take that and calculate the speed of sound. Then do the same thing for the third harmonic. The third, because there is no second harmonic. That's the second sound that you're going to hear. The third harmonic is going to be what? Well, if F was V over 4L for the first one, then F is going to be what for this one? 3 times V over 4L, right? 3V over 4L. Take this equation, rearrange it, solve for V. Do the same thing for trials 3 and trials 4, except trial 3 will be the first harmonic again, trial 4 will be the third harmonic again for the second trial. Get 4 different speeds of sound. They should work out to be pretty much the same value. Then what I want you to do is average them. So if you get 341, 342, 343, and 344, the average is going to be somewhere around 342-ish. Get the average. And then finally, the last question is to calculate the percent difference, which is actual minus theoretical over theoretical. The theoretical speed of sound that you got is this one, 331 plus 0.6 times 20 degrees Celsius. That's the theoretical value. The actual value that you get is this one, the average of the speed of sound that you calculated from your activity. Get the percent difference. Let's see how far we are off of the actual value for the speed of sound when we get it using this resonance tube apparatus. Does that make sense? Got it? Okay, it might take you a few minutes to kind of get the hang of it. Okay, play around with it a little bit. But remember, the first one that you get, depending upon the frequency of your tuning fork, will be somewhere in that 15 to 30, 15 to 35 centimeter range. Don't look outside that range for the first one. Okay, look outside that range for the second one and for the fourth one. All right? If you're not sure if you're hearing what you're supposed to be hearing, then just put up your hand and ask me. We're going to set up in here. We're going to set up in the biology lab as well. It does kind of get a little bit difficult to hear things sometimes if you're hearing resonance taking place over here and over here. It's hard to tell sometimes if yours is taking place over there as well. So we'll split up as much as possible into groups of 3 or 4, as far apart as we can within the 2 labs, within the 2 rooms. And we'll see what we can do. Any questions? All right, let's get at it.